Good afternoon. Good afternoon. Still got a couple still trying to connect. Let's see.
Good afternoon. How was your weekend?
Oh, too short.
Ain't that right? It
How about yours?
was all right. I worked. I mean, that's about as ideal as a weekend can be.
Yeah, man. Yeah, trust me, I'm with you on that. Oh man. So let me see. We covered 5-4, if I'm not mistaken, up to 5-4. First, yep, chose self. Yep, I'm doing that. So we got 6-1. Okay, so yeah, we covered dang, still connecting. I guess we go ahead and get rolling in. So last class we covered up to 5-4. So in chapter 5 is only those 4 sections: 5-1, 5-2, 5-3, 5-4. So today probably just do chapter 6, because chapter 6 is only 2 sections. So we'll do 6-1 and 6-2, and then call it a day. Excuse me. So let's see, are they connected yet? Got one more still out there, so it's all good. So let's go ahead and do 6-1, 6-2. And of course, if anybody have any questions, we can address those before we leave, make sure everybody's good. So 6.1, discrete random variables. A random variable is a numerical measure of the outcome of a probability experiment, so its value is determined by chance. Typically denoted by using capital letters. Excuse me. Give you guys a chance to write it down. Am I still holding on a random variable? All right, so one type of a random variable is discrete random variable, has either a finite or countable number of values. Of course, we'll do an example to make sure we know what we mean by that. But it can be plotted on a number line with a space between each point. In other words, 1, 2, 3, 4, and so on.
A little bit up.
Say again now.
Can you slide up towards the beginning? Because my connection was lacking.
All right, we say beginning all the way to the beginning?
Yes, the first part.
All right, so let them finish this part, at least this part right here, and then I'll scroll up.
Okay.
Mm-hmm. So let's do this, and then we'll take a few minutes to let her get their notes, take pictures or whatever. All right, for those who are copying this, can I scroll up? Everybody okay?
Yeah, I'm good.
Okay. All right, so that was the beginning right there. Let me know when you're ready.
Okay, I got it. Thank you.
Not a problem. So anybody else need any of this before we keep going? Let me know. All right, so that was discrete random variable. The next one is continuous random variable. And this one, instead of it being countable, like 1, 2, or 3, this one has infinitely many values and can be graphed with an uninterrupted line. So in other words, all the values, I'll get my pen back, all the values in between 1 and 0, or all the values in between 1 and 2 are legitimate values. So you'll see in a second what that means. All right, can we scroll up? All right, so we have a few examples. Want to write whether it's discrete or continuous. So I would erase the answers, but they are there. So we just talk about why this is the case. So if you have a number of A's, if you want to know the number of A's earned in a section of statistics with 15 students enrolled, that will be considered discrete because you can actually count that. So in other words, you either have 5 students made an A or not. It would be 6 students, no such thing, 6.5 students made an A, or 7.9 students made an A, 7 students made an A, or 8 students made an A. Whatever the number is, you can actually count that, and it's that definitive answer. That's considered discrete. All right. So if we look at B, the weight of a sandwich at the deli would be considered continuous. So basically, whenever you're dealing with measurement, weighing something or measuring something is going to be continuous. So I won't say measurement, but when you're measuring something with a scale or weighing something, it will be considered continuous, because if your scale is more accurate than mine, then that answer is still correct. So in other words, if I weigh a sandwich and it weighs, I don't know, 5 grams, and then you weigh it, but yours is more accurate and it goes 5.1. Well, both of those answers are correct. And then somebody else could weigh it, and that person goes a decimal further and gives you 5.12. You know, all 3 of those answers are correct. So when you're talking about weighing something, measuring something, and the preciseness of it can be dictated upon the technology you have, then that's considered continuous, a continuous answer. In other words, there's multiple answers that are correct. And like I said, with A, you either have 5, it's either 5 students or it's not. You know, it's just one answer. And that's what makes it discrete. So if you look at the number of cars that pass through a McDonald's in a drive-through and then within the next hour, that's going to be discrete. And so because there's no such thing as 4.1 of a car that's going to drive through the drive-through, either 4 cars drive through or, you know, or not. You know, so that's why that would be considered discrete. And then the speed of a car that passes the state trooper is continuous. Once again, you're measuring something, or you putting something, not putting something on a scale. Here you're measuring something. Your gun is clocking the speed. Once again, if that's that gun, that speed gun or whatever it's called, the gun that measures the speed is more precise than mine, then it would have, it can have some decimal values that will still mean or still be correct as far as your measurement is concerned. So that's why that would be considered continuous. Mhm. All right, and scroll up. All right, probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. So rules for discrete probability distribution. So that first rule, that's the symbolism. You have sigma p of x equal to 1. That just means when you add up all the probabilities, that's equal to 1. Or adding up all the probabilities should be equal to 1. And then the next rule, all of your probabilities are between 0 and 1 inclusive. All right, good. So remember those two rules have to be in place or have to be in play for you to have a discrete probability distribution. Okay. So the next exercise, which of the following is a discrete probability distribution? So they give us 3, A, B, and C. So each one of them for X, you have 1, 2, 3, 4, 5. For A, you have 0.20, 0.35, 0.12, 0.40, and then negative 0.07. For B, 0.20, 0.25, 0.10, 0.14, and 0.49. Then for C, 0.20, 0.25, 0.10, 0.14, and 0.31. So I'll give you a chance to write that down. All right, so once again, we want to see which one of these is a probability distribution, discrete probability distribution. Well, the first one fails rule 2, because remember rule 2 says that your probability has to be in between 0 and 1, and we have a negative 0.07. So that fails rule 2. So that's not a probability distribution. B fails rule 1, because it also says that when you add up your probabilities, they're supposed to equal 1. So that's why B is not a probability distribution. All right. So then that last one, what we see that all of them are in between 0 and 1. And then when you add them up together, they do equal 1. The sum equal 1. So C does represent a discrete probability distribution because it satisfies both rules. All right. Any problems? Any problems? I scroll up. All right. So here I was saying if my math lab asks for a mean of discrete random variable or standard deviation of discrete random variable, just like before, you can just Google or put that in a search engine and find something that calculates that for you. We're not focusing on the calculation of that just like the other one. So just throwing that out there. If you do see that, then you would actually Google or do a search on calculating that, and plenty of free things will pop up if you don't already have something established. I notice I said if here because I forgot if that was one in there or not, but yeah, might be thinking about another class. All right, any questions before we look at 6.2? Scroll up, pretty good. All right. So 6.2, the binomial probability distribution. Binomial probability distribution is a discrete probability distribution that describes probabilities for experiments in which there are two mutually exclusive outcomes. So only two outcomes are possible. That's why it's called a binomial probability distribution. These two outcomes are generally referred to as success and failure. All right. So just an example of that in basketball, success would be considered making the shot, failure would be considered missing the shot. I kind of mentioned that already, but that's it in writing. Experiments in which only two outcomes are possible are referred to as binomial. Left off that piece of the sentence. Binomial experiments provided certain criteria are met. That's what we get into next. All right, so the criteria for a binomial experiment, an experiment is said to be binomial experiment if, still copying black. So the experiment has to be performed a fixed number of times. Each repetition of the experiment is called a trial. Trials need to be independent. That means the probability of one does not affect the probability of another one occurring. For each trial, there are two mutually exclusive outcomes. In other words, they don't have anything in common. You can't miss and make the shot at the same time. You either miss or make. So they have to be mutually exclusive. Oh no, come back. Probability of success is the same for each trial of the experiment. All right, is everybody good? I'm done with the purple. All right, notation used in a binomial experiment distribution, a binomial probability distribution. N is the number of trials of the experiment. P is the probability of success. 1 minus P is the probability of failure. And X is the number of successes in N trials. So X is always going to be between 0 and N inclusive. All right, you okay? How are we doing with the green? Can I go up? All right. So first set of directions under what we just talked about, determine which of the following probability experiments qualify as binomial experiments. For those that are binomial experiments, identify the number of trials, probability of successes, probability of failure, and possible values of X. So basically we'll put numbers to everything we just finished talking about. All right. So first one, an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. Excuse me. All right. So the first thing that they ask us to do is determine whether we have a probability experiment, or whether the probability experiment qualify as a binomial experiment. Remember, it has 4 criteria. So first one, is there a fixed number of trials? Remember, that's the first thing that they said that you have to fit. There has to be a fixed number of trials. So the answer is yes. It says shoot the ball 3 times. As the person to shoot the ball 3 times. Are the trials independent? Yes, the probability of making a shot does not change from shot to shot. So if you shoot it one time, it does not affect the probability of the next shot going in. So the trials are considered independent. Are the events mutually exclusive? The answer is yes, because you cannot miss and make a shot to miss or make. So they are exclusive, mutually exclusive from each other. They don't have anything in common. And is the probability of success the same for each shot? The answer is yes. He or she is a historically 80% free throw shooter. And so your history doesn't change just because you miss a shot or make a shot. So those are 4 things you have to make sure you have a yes to before you can go any further. All right. Okay, so just say right there, it is a binomial experiment because it meets all 4 criteria. And we have to go to the next part of this same question. When it says if it's a binomial experiment, then label, number of trials and probability of success and all that stuff. So if I don't read, all right, so here we go. So n is equal to 3. That's the number of trials. 3 shots. Probability of success is 80%, so that's 0.8. Probability of missing is going to be 1 minus that 0.8, which is 0.2, 20%. So probability of failure, which is missing a shot. And then X is going to be from 0 to N. So that's 0 to 3 for us. 0 means that the person missed all the shots. 1 means you make 1 shot. 2 means you made 2 shots. And then 3 means you made all 3 shots. So X is always based on your successes. What's the chance of you doing or being that successful? Any questions on that one before we go to the next one? All right, next one, a probability experiment in which 3 cards are drawn from the deck without replacement and the number of aces is recorded. Give you a chance to write that. All right, so let's go through the criteria. Is it performed a fixed number of times? The answer is yes, because we're pulling 3 cards out. Are the trials independent? So we can stop right here because the answer is no, because it says without replacement. So that means you're not replacing the card you just took out. So if you have a 52 card deck and you pull a card out, now you have 51 cards. So now the probability changes every time you pick out a card. Now, if it said with replacement, then the trials would be independent because you will be putting the card back. The number will be 52, and you still have the same number of cards that you're dealing with, the same type of cards that you're dealing with. But because it says without replacement, the trials are not independent. And so it's not a binomial experiment because it does not meet all criteria. All right, scrolling up, everybody good? If we look at this last one like this. So according to a recent Harris poll, 28% of Americans state that chocolate is their favorite flavor of ice cream. Suppose a simple random sample of size 10 is obtained, and the number of Americans who chose chocolate as their favorite ice cream is recorded. All right, so let's check our 4 criteria. Are the experiments performed at a fixed number of times? The answer is yes. We have 10, sample size of 10, so we'll be picking out 10 people. Are the trials independent? Yes, picking out a person has nothing to do with picking out the next person. All right. Are the trials mutually exclusive? Yes. Either ice cream is your favorite color or favorite flavor. I mean, either chocolate ice cream is your favorite flavor or it's not. You know, when you say favorite, it didn't say if you like ice cream or chocolate ice cream. He's talking about it being your favorite flavor. So either chocolate ice cream is your favorite flavor or it's not. So there's no you can't have two favorites. One is your favorite, and then the other one you may like it, but it's not your favorite. And then the probability of success is the same for each. Yes, because the probability is 28%. 28% of Americans, the whole population of America, choose chocolate as their favorite flavor. All right. Questions. All right. So this experiment is a binomial experiment because it meets each of the criteria. So once we've established that, then we can go ahead and do the other pieces, notation. So number of trials is 10. Probability of getting somebody who choose chocolate as their favorite is 28%. Probability of getting somebody that's not or does not want chocolate or does not have chocolate as their favorite is 72% because it's subtracting 1 from that 28. We're subtracting 28 from that 1. And then the number of X will be 0 to N, which is 10. So 0, the probability that when you choose 10 people, none of them chose chocolate as their favorite. And then 10 is the probability that when you choose 10 people, all 10 will choose chocolate as their favorite. And then of course, all of those numbers follow suit. All right, any questions? All right, can I scroll up? So last new type of thing that they're going to introduce in this section, binomial probability distribution function. So the probability of X, so our X was my pen. X is going, you're talking about these, the probability of these occurring is what we'll plug in for X. In other words, the probability that if you chose 10 people, 9 of them, would have chosen chocolate as their favorite. That's what we're going to put in here. So this is the formula. So we have N, X, and P that we need to know the numbers for. C is the combination formula. So we didn't talk about that because they're not asking you to actually calculate it. Just have to put it into the formula, which what I'm going to tell you to do is actually find an app that can do it for you. Once again, binomial probability distribution function, and just put calculator at the back of it. I'll show you. Yeah, I can pull up one to show you one that works real well. But X represents the number of successes. N is the number of trials. P is the probability of success. All right. You scroll up, pretty good. All right. So according to CTIA, 41% of all US households are wireless only households. That means no landlines. In a random sample of 20 households, what is the probability that exactly 5 are wireless only? All right. So here, just establishing our pieces like we did in the previous. 41% is 0.41. That's the probability of success. In other words, picking out a household that is wireless only. 1 minus that 0.41 is 0.59, probability of failure. Then the number of trials, it says of a random sample of 20 households. So 20 trials, and then X is going to go from 0 to 20. All right. Gonna scroll up, everybody good? So plug in that stuff into the formula. So we want to know what's the probability of exactly 5 are wireless only. So in other words, out of 20, 5 were wireless only. The probability of that happening. So this is the formula right here, 20C5.41 raised to the 5th power, 1 minus 0.41 raised to the 20 minus 5. So if you need to know how to use your calculator, you don't know how to put it in your calculator, then feel free to get with me, whether it be at the end of class or outside of class. So we look at what type of calculator you have and see what buttons you're gonna have to press to put this in the calculator. Now, what you could do though, let me share my screen. Notice I went to Google, typed in binomial probability distribution calculator. So that's what we're dealing with. And this first one, StatTrek, works fine. Can't give an account for every website, but this one worked fine. So you plug in the values accordingly. So the probability of success is 0.41. Number of trials, 20. And in this case, we're looking at the number of successes being 5. And so right here, I don't know if it'll let me highlight. No, it won't. Right here, 0.0656, it says probability of X being equal to X. And we're talking about 5. So you look at the notes, that should have that value up. So there you go. That's at this, that's the percentage. Converted decimal to percent, but it gave us this one right here, 0.0656. And always make sure you pay attention to my math lab and how they want the answer to be inputted, and then how many decimal places they want. All right. Now, if you go back to that, depending on what you want, they may give it to you already. Notice this second row, second grade box, the probability of values less than that. So you're talking about the probability of choosing 4, 3, 2, 1, and 0. And then the next one, the third row, the third grade box is less than or equal to. Fourth grade box is greater than. So you're talking about 6 and up, all the way to 20. And then greater than or equal to is 5 up to 20, equal to 5 and up to 20. So yeah, this pretty much calculates it all for you. All right. So this statement right here, if they ask you a statement, where they give you a choice of statements to choose from as far as your conclusion is concerned. If they say, we talked about this before, in 100 trials of this study, and in parentheses, I put if we survey 20 households 100 different times. So that's what that means. We would expect about 7 trials to result in 5 households that are wireless only. And so you see where we got the 7 from. You take that 100 that they gave you, multiply it times that 0.0656, and that's about 6.56. So now if they said in 1,000 trials, you would have multiplied this by 1,000, and there would have been about 66 trials, or they could have said 70. They'll give you this number right here, and you just need to make sure it matches up when you multiply this times this. Any questions? Any questions? All right, let me scroll to the next one. All right, so this next one is fewer than 3 are wireless only. So you're talking about the probability of getting 0, or the probability of getting just 1, or probability of getting just 2 out of that 20. You're talking about less than 3. So now you could do them individually. And that's what I did here, putting them all in individually. Or if you use the website that I just used, you could type 3 in where we did 5, and then do the less than. So I'll show you that in a second, but I'll give you a chance to copy this down. And calculating each one of those individually, adding them together gives you 0.0028. All right. Can I go back to that screen real quick? So I'm still copying. All right. So go back here. So instead of 5, you can put 3. And we talk less than, that would be this second gray box. So you see how it's 0.00278. So 0.0028 would be that rounded to 4 decimal places. So that's how you can use this website. But of course, you don't have to use that website, but help you out a little bit. All right. So the next one, at least 3 are wireless only. So if you're saying at least 3, that means 3 is the least of your options, and then greater than that. So that's why we have greater than or equal to. We say at least 3. So you're talking about, once again, probability of 3, probability of 4, probability of 5, all the way up to the probability of 20. So if you wanted to, what you could do is the complement rule. we have less than 3, which is 0.0028. So since we want to know greater than or equal to, we can subtract less than, which is everything else. And that'll give us 0.9972. Or if you are using the website, if you go back to it, show you that real quick. Greater than or equal to is that last box. Notice how it says 0.9972. So that's it right there. Greater than or equal to. Any questions on that before we look at the last one? All right, can I scroll up? So then our last one, the number of households that are wireless only, that is between 5 and 7 inclusive. So we're looking at 5, 6, and 7. When it says inclusive, that means you're including those values of 5 and 7. So 5, 6, or 7. All right, so now for this one, got to do 5 probability of 5 plus probability of 6 plus probability of 7. Now I do know that I've seen a website where you can do, do it like this and it'll calculate that for you. This one though, let me look back at it. Yeah, that one doesn't have it so that you can do, the boundaries, having probability of 5 less than or equal to probability of 7. So this one, you would just have to do each one of them individually. If you're using the stat trick, you just plug in each one of them individually, plug in the 5, get the one for equal to 5, plug in the 6, get the one equal to 6, plug in the 7, get the one equal to 7. So you're just changing that number and getting that value for each. And so you will get each one of these 3 individually, add them together, and that'll give you 0.3381 as a probability. All right, any questions? No questions? Everybody good? All right, so test 3 is 5.1 through 5.4, 6.1 through 6.2. Let me see, what have I done as far as I kick me out. Hold on 1 second. Let's see how many weeks we have left. Got 1, 2, 3, 4. Okay. So yeah, 5, 6 test. I went ahead and made that available for you guys to do. I haven't decided. We should have time for, yeah, if we do it this way, we'll have time for the other one. Okay. So yeah, so 5, 6 is available. 5, 6 test is available. So make sure, you guys get on top of this thing. If you have any questions, always feel free to ask. Next class, I will open up the floor for questions first. See if you guys have any. Before we close out, did anybody have any questions today? Anybody have anything? All right. So, like I said, that's it for chapter 6. There's no real rush to have to go into anything new. You guys know what your assignments are. And let me this. That. And most of us are on track. Got a few, got to play catch up a little bit, but most of us are on track, so we're in a good space. Make sure we are getting these tests and everything taken care of so that it's we're not too far behind. But yeah, any questions before we close out? Any questions? All right. So that's it for today. You guys have a good one. Be safe and let me know if you have anything that I can help you out with.
You too. Have a good rest of your afternoon.
Thanks. You do the
Thank you.
same.
Take care.
Thank you. Take care.